Hello friends, in this video I'd like to solve the following problem from the Finnish high school mathematics competition, final round 2012, problem number 3. So we wish to prove that the sum k to the power k minus 1, quantity minus 1, is divisible by the number k minus 1 squared for every integer k which is greater than or equal to. So my hint for this problem is probably a classic application of the binomial theorem. Give it a try and see you in a moment. Okay, so I hope that you tried to solve it. So let's take our number and let's write it like that. It's k minus 1 plus 1 to the power k minus 1 minus 1. And now let's use the binomial theorem. The binomial theorem, which states that this sum, a plus b to some power, is the sum over j from 0 up to k minus 1 of k minus 1 choose j, and k minus 1 to the power of j, and a bit artificially I will write 1 to the power k minus 1 minus j, everything minus 1. Okay, now let's simplify it a little bit, and also let's separate the first two terms of our sum. So let's write our term for 0 separately, and term for j equals 1 separately. Then we have our sum from j equals 2 k minus 1 . I run out of space, unfortunately, but I will move everything a little bit. Oh, now I have space. Very well. So we have here j and finally minus 1. And now let's look. This number, it's simply 1. 1 minus 1, 0. The second number is k minus 1 times k minus 1. So it's k minus 1 square. And then we have sum from j equals 2 to k minus 1, k minus 1 to choose j, k minus 1 to the power of j. And now let's look. We want to prove divisibility by k minus 1 squared. This is obviously divisible by k minus 1 squared. And because j is 2 or higher, this part is also divisible by k minus 2 squared. So we have a sum of two numbers divisible by k minus 1 squared, which implies that k minus 1 squared divides k to the power k minus 1 minus 1, which closes our proof. Thank you for watching and see you next time.